Welcome to video 10A. This is about surface area and nets in our new Module 19. So we're going to be focusing specifically just on the nets page. That's why I photocopied them. You can see here that a net is a diagram of the surfaces of a three-dimensional figure that are going to be folded to form a three-dimensional shape. Okay, so we're just talking about, when we're talking about surface area, guys, I want you to think about taking whatever shape it is and wrapping it up in some wrapping paper. So as we do our notes today, we're going to be filling in this table they have in your book here, and we're going to be starting by talking about the type of solid that we're going to have. That's just the name of the three-dimensional figure. That's in the first column. Then we're going to be drawing a three-dimensional example of it, and that's just basically a diagram. And I'll help you with the three-dimensional pieces of this. Then we're going to talk about the faces of the three-dimensional shape. And if you think about the word surface area, surface has the word faces in it. So really what we're doing is we're just kind of talking about what are all of the flat sides of the shape. And then finally the net, that's our new topic for today, is what happens when we unfold each of these shapes. So let's fill in this table. The first example, the row that we have there, of course we can tell that it's a box, which is otherwise known as a rectangular prism. We can see the dimensions that are drawn in. 4 by 2 by 1.5 are the length, the width, and the height. And as far as the surfaces go, I think we can think of them all as rectangles, of course, but as a top and a bottom side, a left and a right side, and as a front and a back side. So they're going to be three congruent pairs of rectangles that are going to make up all the surfaces of this three-dimensional shape. So if I thought about surface area, I'm really adding up 6 different rectangles. And if I go to the net, you can kind of see where we're corresponding these sides here. The left and the right ends, the front, and then the back side there. And I'll make back have a BK, just so you can see the difference between that and bottom. And then there's my bottom face, and then there's my top face. I don't know if you can visualize that kind of being folded back together, but that's your rectangular prism net. So the next thing I want to do is to figure out what the second row is going to have under the example diagram here for a triangular prism. This can be a little tricky to draw, but I'd start just with a really basic right triangle. And then to make it in 3 dimensions, the easiest way is just to kind of extend off of the 2 top corners there, a side, and then call that the back side. And then of course in 3 dimensions we know that any face that we can't quite see but we know is there, we're going to create with dotted lines. So then you can see that the surfaces on this one, or the faces, are a pair of congruent triangles, and that's the front triangle and the back triangle, and then 3 rectangles that make that up. So that our challenge next is to go ahead and to draw the net. Those are my 2 congruent triangles. And then there's my 3 rectangles. So now when I draw the net, I'm going to start by drawing the base of the whole entire prism, the bottom rectangle, if you will. Then we're going to attach the folded down front side. And then we're going to attach the folded down back side, back face. And then we need to unfold two other rectangles. The first one is a little bit longer, you can see, and I'm going to call that the hypotenuse rectangle, if that makes sense. And then the other the other rectangle on the other side is, we'll just call that the left face. So I hope that makes sense to you for the net for that triangular prism. We're not going to be actually drawing these, but I think that it's a really healthy exercise to go through to really start to be able to visualize this idea of surface area. Okay, on the next page, we've got a new net that we are given this time, and we need to go backwards to actually drawing the diagram. So we can see that the faces this time are a rectangle and then two pairs of congruent isosceles triangles. So when we fold these faces of the net, the sides back up, I hope that you can see that this is going to become a rectangular pyramid. And remember, in 3 dimensions, the rectangle, we'll put a right angle in the corner there. It's a 6 by 11 rectangle. But even though there's a right angle in the corner there, we're looking at this on the side, remember? So we kind of have to start by drawing the rectangle as a parallelogram. And then I think the easiest way is simply to put a dot above that and then trace down to all 4 corners of that parallelogram, and there's your pyramid. And then again, we're not going to be really focusing too heavily on you actually constructing these diagrams, but I think it's a good exercise to go through and understand how they get put together. So we have a rectangular pyramid. Then the last row of our table here is talking about finding out what the surfaces are when I slice a cylinder. And if I think of this as a soup can, I can like slice the label part of it and think about unrolling the label. And hopefully you can understand when I do that, I'm going to get one big label rectangle, just like when you saved Campbell soup labels in elementary school. The dimensions of this rectangle are important. We'll get to that in a second, but the soup can lid and the soup can base have to be attached to that. You remember we saw that in the beginning of the video. So there's the top circle and the bottom circle. And now let's talk about the dimensions here. Of course, we know the radius of our circle is 7. And so when we think about what that makes the length of the entire unrolled rectangle, I hope you can see that that's going to be the unrolled circumference of the circle, which of course we know is the formula 2 pi r. And using r as 7, we're going to get 14 pi for the length of that rectangle. And really the only dimension we need left over is now what the height of that rectangle is. We know we have 2 congruent circles for the faces and 1 long rectangle. Whose dimensions here are the same as the height, 12 feet here, just like the height of the cylinder. And then the base is your circumference. Capital C times H is going to be the area of that rectangle. So that's it for writing our nets, and just want to let you know that in our next video, we are going to actually be calculating the surface areas of cylinders and of prisms.